The universe rarely sends us messages, and when it does, they often arrive in the most unexpected ways, silent, mysterious, and fleeting. But in July 2025, astronomers in Hawaii caught sight of something extraordinary. A cosmic postcard from the depths of interstellar space, a new visitor named 3I/Atlas. Unlike the comets that regularly grace our skies, this object's path was hyperbolic, a mathematical signature that proved it was not bound to our sun. It was a true wanderer, traveling from a distant, unknown star system. Only the third confirmed interstellar object after Oumuamua and Borisov, 3I/Atlas, arrived with a faint ghostly glow, a subtle but unmistakable sign of its alien origin. As it approached the warmth of our sun, its icy body began to release a shimmering cloud of gas and dust, forming a glowing coma. This transformation revealed it as a relic from another star system, carrying secrets from a place we may never visit. Scientists knew they had only a brief window to study this cosmic messenger before it slipped away, vanishing once more into the vastness of the galaxy. This time, the discovery came early enough to spark a global campaign of observation, uniting astronomers across continents in a race against time. The world's most powerful telescopes, including the James Webb Space Telescope and massive ground-based observatories, prepared to unlock the secrets hidden within this interstellar traveler. 3I/Atlas posed no threat to Earth, allowing astronomers to focus purely on the science, on discovery, not defense. Each photon streaming from its coma carried precious clues about its birthplace, hints of an environment far beyond our own, shaped by forces and histories we can only imagine. What kind of star did it once orbit? Was it ejected by a violent encounter, or did it drift away over eons? How old was this cosmic wanderer? What was it made of? Did it carry the same ices and minerals as comets from our own solar system, or something entirely new? The answers were hidden in its faint, ancient light, and for the first time, humanity was ready to listen with tools more powerful than ever before. The stage was set for a remarkable encounter, one that could change our understanding of the cosmos forever. For a guest as rare and mysterious as 3I/Atlas, only the most advanced instrument in humanity's arsenal would suffice. Enter the James Webb Space Telescope, a marvel of engineering and the most powerful space observatory ever built. On August 6, 2025, JWS turned its golden mirrors toward the comet using its cutting-edge near-infrared spectrograph known as NIRSpec, to begin a new chapter in cosmic exploration. This was far more than a simple snapshot. NIRSpec meticulously dissected the faint light from 3I/Atlas, breaking it down to reveal the comet's unique chemical fingerprint. Tracking such a fast-moving and faint visitor was a challenge, but JWST's precision delivered a spectrum brimming with hidden clues about the comet's origins. Scientists eagerly searched the data for signatures of ices and gases, water, carbon monoxide, and carbon dioxide, hoping to decode the comet's story. To their astonishment, 3I/Atlas's spectrum revealed an unusually strong carbon dioxide signal, unlike anything seen in typical solar system comets. This was a major surprise. CO2 dominated the spectrum, far more than in any comet previously studied by astronomers. The unexpected finding shifted the entire investigation, hinting that 3I/Atlas might have formed in a fundamentally different environment than comets from our own solar system. Thanks to JWST's extraordinary sensitivity to infrared light, astronomers could now see details that had always been invisible to other telescopes. The comet's chemical makeup became a window into the environment of its distant home system, offering a rare glimpse into the building blocks of other worlds. Was 3I/Atlas born in a cold, distant region of another star system, or did it come from somewhere even stranger, shaped by forces we have yet to understand? The first data from JWST began to peel back the layers of mystery, offering tantalizing hints and sparking new questions. At last, the message from the stars was finally coming into focus, promising discoveries that could change our understanding of the cosmos forever. Most comets exhale water vapor as they near the sun, but 3I/Atlas was different. JWST revealed the highest carbon dioxide to water ratio ever seen in a comet. This chemical anomaly demanded explanation. In our solar system, a comet's composition depends on where it formed. Water freezes closer to the star, CO2 farther out. The abundance of CO2 suggested 3I/Atlas formed near its home system's carbon dioxide frost line. Scientists theorized a thick, insulating crust might trap water ice deep inside, letting only volatile gases like CO2 escape. This unique structure could explain the comet's strange behavior. 3. I/Atlas challenges our models, reminding us our solar system is just one example among billions. Its carbon dioxide-rich breath forces us to rethink the diversity of planetary systems. The universe once again expands our perspective. The chemistry of 3I/Atlas sent theorists scrambling for answers. One idea: it formed in a CO2-rich zone of its protoplanetary disk, making it intrinsically carbon dioxide heavy. Another theory: billions of years in interstellar space bombarded by cosmic rays altered its surface, enriching it in CO2. Distinguishing between these origins is crucial. Each tells a different story about its home system or its journey. Further observations could reveal if the CO2 comes from the whole comet or just a processed surface layer. The presence of other molecules like carbon monoxide adds more clues. By comparing these ratios to solar system comets, scientists reconstruct the comet's history. It's a cosmic detective story piecing together evidence from light years away. Each spectral fingerprint is a clue to a crime scene billions of years old. The mystery of 3I/Atlas deepens with every observation. The true wonder of 3I/Atlas isn't just its chemistry, but the incredible story of its origin in both time and space. This comet is not just a visitor, it's a survivor from a distant past, carrying secrets from the dawn of our galaxy. Astronomers traced its path to the Milky Way's thick disk, a region filled with ancient stars, some of the oldest in our galaxy. This thick disk is a stellar graveyard, a place where the earliest generations of stars once shone. This means the comet is likely around 7 billion years old, predating our Sun by over 2 billion years. It was born when the Milky Way itself was still young, and the universe was a very different place. 3I/Atlas is a relic from a time before our solar system existed, a frozen witness to cosmic events that shaped the galaxy long before Earth formed. It's the oldest comet ever observed, a time capsule from a lost era, preserving the chemistry and dust of a forgotten epoch. When it formed, Earth and the Sun were just possibilities in a distant cloud, drifting in a vast nebula that would one day give birth to our solar system. Its journey through the galaxy makes it a messenger from a different epoch, carrying information across billions of years and countless light years. Studying its composition lets us test models of how the galaxy's chemistry has changed over time, revealing how elements and molecules have evolved since the earliest days. 3I/Atlas offers a direct glimpse into the raw materials of planet formation in the early Milky Way, showing us what the building blocks of worlds looked like before our Sun was born. In its light, we read the history of a 7-billion-year-old galaxy, uncovering stories written in ice and dust from the galaxy's youth. This is cosmic archaeology at its finest, a chance to hold a piece of the galaxy's ancient past and unlock the mysteries of our cosmic origins. What kind of system birthed 3I/Atlas? Its properties offer clues. Thick disk stars are metal-poor, with different ratios of elements than our Sun. This would shape the ices and chemistry of their comets. A carbon-rich, oxygen-poor disk could explain the comet's CO2 abundance. Ejection from its home system likely required giant planets whose gravity flung it into interstellar space. 3I/Atlas is evidence of dynamic planet shuffling in an ancient system. Each new observation adds detail to this portrait of a lost world. The comet is a fossil record of a vanished planetary nursery. The fleeting visit of 3I/Atlas sparked a worldwide scientific campaign. Space agencies and observatories raced to gather data before the comet faded into darkness. JWST and Hubble combined their strengths, infrared, ultraviolet, and visible light, to build a complete picture. New missions like SphereX and ground-based telescopes joined the effort, tracking the comet's brightness and refining its orbit. Scientists shared data openly, accelerating discovery. This collaboration highlights the importance of interstellar objects as our only direct samples from other star systems. Each visitor is a rare opportunity to study the galaxy's diversity. The intense focus on 3I/Atlas is preparing us for future interstellar encounters. What we learn now will shape how we study the next cosmic messenger. The race to understand 3I/Atlas is science at its most urgent and inspiring. 3I/Atlas is more than a curiosity. It's a window into the galaxy's past. For centuries we knew only our solar system. Now interstellar objects reveal the diversity of planetary systems. 3I/Atlas, ancient and thick disk-borne, bridges planetology and galactic archaeology. Its composition tests our models of how the galaxy evolved and how planets form in different environments. Each new observation adds to the puzzle, revealing the interconnectedness of the cosmos. These objects remind us our solar system is not an island but part of a vast dynamic galaxy. Material, and perhaps even life, can travel between stars on comets like this. 3I/Atlas is a messenger not of aliens but of the universal processes that build worlds. Its journey connects our origins to the grand story of the cosmos.